Hi, here we are given if r is a constant such that mod of this whole quadratic is r has exactly 3 distinct real roots, then the value of r is what? Now mod of this whole thing we are talking about. So there are two cases possible. Case 1, when the expression inside this mod x square minus 4x minus 13, if this is greater than or equal to 0, this is the first thing. Or case 2 is when this expression inside, which is x square minus 4x minus 13, is less than 0. So if these are the two cases that we have. So if this is positive, then mod will be removed as it is. So we get the equation x square minus 4x minus 13 is r, which effectively gives us the quadratic equation x square minus 4x minus 13 minus r is 0, right? And in this second case, if this whole thing is negative, mod will be removed with a negative sign multiplied. So we'll have minus of x square minus 4x minus 13 is equal to r. So taking all these terms on the right side, we'll have x square minus 4x minus 13 plus r is equal to 0. Fine, this is what we have. Now what's given is, so what we effectively have is two quadratic equations. One is this, the other is this. So now if there are two quadratic equations, we'll ideally have 4 real roots. But here we have that there are exactly 3 distinct real roots. Now how is it possible that two quadratics, a quadratic generally has 2 real roots. So two quadratics should have 4 real roots, but there are exactly 3 distinct real roots. So this is possible when the one quadratic has 2 distinct roots, the other quadratic has real but equal roots, right? So the condition to have 3 distinct roots when there are 4 possible is that one quadratic will have 2 real but distinct roots and the other quadratic will have 2 real and equal roots, right? So let's take cases. So one of the possibilities is that either this quadratic has 2 distinct roots and this quadratic will have 2 equal roots, or this quadratic will have 2 equal roots and this quadratic will have 2 distinct roots. These are the cases possible, right? So let's check. If this quadratic has 2 equal roots, right? Now when are roots equal for a quadratic? When the discriminant is equal to 0. And when does a quadratic have distinct roots? When the discriminant is greater than 0, right? So here d should be greater than 0 and for this the d should be equal to 0. So let's see, if d is equal to 0, the discriminant of this equation is b square, which is minus 4 whole square, minus 4 into a into c, the constant part, which is minus 13 plus r. This should be equal to 0. So now what we have is 16 is equal to taking all these, or let's not just take. So we'll have minus 4 into minus 13 is plus 52, minus 4r is 0. 16 plus 52 is effectively 68, which is equal to 4r. So this gives us r is equal to 17. So this quadratic will have equal roots when r is equal to 17, and now you have to make sure when r is 17, the discriminant of this equation should be greater than 0. So the discriminant of this equation will be b square minus 4 square, which is 16, minus 4 into a, which is 1, into c. Now c here will be minus 13 minus 17, so minus 30, c is minus 30. Now obviously minus 4 into minus 30, this is a positive number and this will also be positive. So this will definitely be greater than 0. So no need to worry. If r is 17, then you have the roots of this equation will be equal and the roots of this equation will be distinct. So you will have basically 3 distinct roots, 2 from here and 1 from here. And if you want, you can calculate the roots as well. The 2 roots of this equation will be different from 1 root of this equation, hence there will be 3 distinct roots. So r equals to 17 itself is the answer. Option C is the correct answer here. And since we don't have any of the options like 2 of these or anything like that, so we can mark option C and move ahead to the next question. But if you do want to check, what if this is the case? Now if this is the case where this quadratic has equal roots, then the discriminant of this quadratic should be 0. So the discriminant of this quadratic is 16 minus 4 into a into c. C here is minus 13 minus r, which is 0. Okay. So this will give us minus 16 plus 52. Minus 16 plus 52 is again 68. And then we'll have a plus r here. Plus r goes on the right side, becomes minus 4r. So 68 is equal to minus 4r, hence r is equal to minus 17. Now r equals to minus 17 is not there in the options, right? So no need to check this part here. R equals to 17 itself is the right answer. But if you do check, what will happen is when r is minus 17, the discriminant of this equation will come out to be greater than 0. So even for r minus 17, this quadratic will have equal roots and this quadratic will have distinct roots. So you'll have total 3 distinct roots when r is minus 17. So both the values of r are possible, plus 17 as well as minus 17. But since options have only plus 17, we will mark option C and move on. Thank you.